So let us move on with the first paragraph, that is question number 46, 47 and 48. Consider the lines L1 is equal to 4x minus 3y plus 13 equals 0, 4x minus 3y minus 37 equals 0, 3x plus 4y minus 34 equals 0, and the line L4 as 1 plus lambda into x, 1 minus lambda into y minus 24 equals 0, where lambda is a parameter. P alpha comma beta is the center of the circle which touches the line L1 equals 0, L2 equals 0 and L3 equals to 0. Then what is the minimum value of alpha plus beta? So students, in this question, what do we have to observe is that L1 and L2 have same slope. So basically they are parallel to each other. Okay. We should also know the distance between them. And L3 equals 0 has slope which is the negative reciprocal of these two slopes. So this is a line which is perpendicular to them. Now, let us mark the equations of lines. 4x minus 3y plus 13 equals to 0. 4x minus 3y minus 37 equals to 0. This distance D, the distance between two parallel lines D will be C2 minus C1, that is 50, divided by root under 4 square plus 3 square, that is 25. So 50 by 5, that is 10. Okay. Now students, this line, the perpendicular line, has the equation 3x plus 4y minus 34 equals to 0. There are two possibilities of the circles here. First circle can be something like this. Okay. Touching all the three lines. So we have to be careful like this. And then another possibility is on this side. There are definitely two possibilities. That is why they are asking minimum value of alpha plus beta. So the circle has to have a radius of 5 because the diameter is 10. And if the radius is 5, we can easily write down the equation of line passing through centers. That will be the line which will be equidistant from these two lines. That will have the equation 4x minus 3y minus 12 equals to 0. Okay, so this is a point which is the point of intersection of 4x minus 3y equal to 12 and 3x plus 4y equal to 34. So this point has the coordinates, let us say it is A. A point has the coordinates 6, 4. Now you need to solve the equations parametrically. Let it be P and let it be Q. AP and AQ both have distance 5 because it is the radius. Okay, you are required the coordinates of point P and point Q, which are at the distance of 5 units from a point A, that is 6, 4, on the line 4x minus 3y minus 12 equals 0. Using the parametric form, I have x minus x1 upon cos theta is equal to y minus y1 upon sin theta is equal to plus minus 5. Where, what is the value of tan theta? 4 by 3. Okay. So if tan theta is 4 by 3, sin theta is 4 by 5, cos theta is 3 by 5. Okay. Now from here you will get the value of x comma y as, you will get 2 points 9, 8 or 3, 0. Okay. So we need alpha plus beta minimum. Alpha plus beta has two possible values, 17 or 3. So option number A is the correct choice. Okay. Let us move on to next part of this paragraph, 47. Question number 47 says that if L1 equal to 0, L2 equal to 0, L3 equal to 0 and L4 equal to 0 form a quadrilateral, then the number of integral values of lambda. So students, drawing these lines on the coordinate plane, this is L1, this is the first line, this is the second line parallel to it, and this is the third line L3, 3x plus 4y equal to 34. So both the intercepts are positive, perpendicular to both the lines. L1 equals 0, L2 equals 0 and L3 equals 0. The points are 2, 7 and 10, 1. Now students, L4 is a family of lines. That is, L4 equal to 0 gives me, that is, x plus y minus 24 plus lambda times x minus y equals 0. Okay. So that means y equal to x and x plus y equal to 24. Their intersection point is, let us say P 12, 12. So 12, 12 lies on the first quadrant above this line, below L1, above L2. So this is 12, 12, let us say. Now any random line passing through P will form a triangle if it is passing through this point or this point. Otherwise it will always form a quadrilateral, because if it is passing something like this, then there is no problem. But it should not pass from here to here, from this point to this point. It should not pass something between this triangle. Okay, so this particular line, let us say it is PA and PB. Slope of PA will be 5 by 10, 1 by 2, and slope of PB will be 1 by 2, 11 by 2. So students, 1 by 2 is the slope of PA, 1 by 2, 11 by 2 is the slope of PB. The slope of this variable line should not lie in the interval 1 by 2 to 11 by 2, because if it is lying in this interval, the line will be passing something like this, and there will be not a quadrilateral formed. In all the other cases, a quadrilateral will be formed. So we have to take M not lying between 1 by 2 to 11 by 2. So lambda plus 1 upon lambda minus 1 not belongs to 1 by 2 to 11 by 2. It should not belong to this interval. Okay, so from here you are going to get lambda as minus 2 minus 1 0 1. This is the complement answer of this condition. Okay, you're going to solve this condition. You're going to get some interval which is going to run from minus infinity to some number and some number to infinity. So the remaining values of lambda here, they complement with the real values, because we need the integral values over there. How many values of lambda are possible? 4 values of lambda. This is a slightly lengthy inequality, but it is very easy, so you can solve it yourself. Okay, let us move on to question number 48. Question number 48 says that the equation of inscribed circle of the cyclic quadrilateral formed by the lines L1 equals 0, L2 equals 0, L3 equals 0, and L4 equals 0. So let us copy the diagram of the previous question. So this is the diagram. So now we know that P lies above this particular portion. So we'll have exactly one circle which will be something like this. So we will have exactly one circle which will be lying above this blue line and which will be something like this. So the center will be 9, 8 as we calculated earlier. C. So the equation is x minus 9 whole square plus y minus 8 whole square is equal to 5 square. That means option number A is the correct choice. Okay, so 48 has option number A as the right choice. Let us move on to next paragraph, that is based on 49, 50 and 51. Okay, so next paragraph is based on consider the hyperbola xy equals 4 and the line y plus 2x equals 4. Tangent at any point P on the hyperbola intersect the coordinate axis at point A and point B. Then the locus of the circumcenter of OAB is equal to what? So this is a rectangular hyperbola, xy equals to 4. Parametric coordinates on this parabola can be taken as 2t, 2 by t. And the equation of tangent at any point P on this hyperbola can be written by the formula t is equal to 0. That means students, this is x into 2 by t, xy1, y into 2t divided by 2 minus 4 is equal to 0, which gives me x by t plus yt is equal to 4. Now students, xt plus yt equals 4. This line intersects the x-axis at a point 4t, 0 and it intersects the y-axis at a point 0, 4 by t. I need the locus of the circumcenter. This is a right angle triangle. Circumcenter, let us say C, will be the midpoint of the hypotenuse 2t, 2 by t. So locus is xy equals 4. So it is very same as the hyperbola itself. Okay, that means it is a rectangular hyperbola, hyperbola with eccentricity root 2. Okay, option number C is correct. Let us move on to 50. Question number 50 says that the given line L1 intersect x-axis at point R. So point R is 2, 0. If the line through R intersect the hyperbola at S and T, then the maximum value of RS into RT. So students, drawing this particular diagram, xy equals to 4 is a hyperbola which is having coordinate axis as the asymptotes, x-axis, y-axis. Point 2, 0 is over here. A random line will be something like this, R, S, T. I need the maximum value of RS into RT. So let us write the equation in parametric form. S can be given as 2 plus R cos theta, comma R sin theta, where R and theta are variable. But this point S as well as point T can be assumed within the same coordinates, and both S and T lie on the curve xy equals 4. So let us put the product equal to 4. R cos theta plus 2 into R sin theta equals 4. That means R square sin theta cos theta plus 2R sin theta minus 4 equals to 0. Okay, students, this is a quadratic equation in R. Now I need the product RS into RT is R1 into R2. Okay, so R1 into R2 will be minus 4 upon sin theta cos theta, and that is minus 8 by sin 2 theta. So what is the minimum value of RS into RT? We should take the mod because it is the distance. Okay, the minimum value of RS into RT will occur when sin 2 theta is maximum. Sin 2 theta maximum is 1. So the answer is 8. Okay, this is the maximum value. Okay, so this is the maximum value. Option number D is the right choice. Fine. Let us move forward to question number 51. Question number 51 says that if the line y equals mx plus c is a common tangent to the hyperbola xy equals 4 and y square equals to 8 into x plus 2, then what is the value of 2m minus 3c? So again, it is a very simple question. What do we have to do? We have to write down the equation of tangent to this circle. Y is equal to m times x plus 2 plus a by m. So this is mx plus 2m plus 2 by m. So that means when you are going to solve this line y equal to mx plus 2m plus 2 by m with the hyperbola xy equals 4, you are going to get real and equal roots. D equals to 0. So that means mx plus 2m plus 2 by m, that is the value of y, into x is equal to 4, has discriminant 0. That means mx square plus 2mx plus 2m plus 2 by m into x minus 4 equals 0. From here, discriminant equal to 0. 4 into m plus 1 by m whole square plus 16m equals 0. Okay, from here you will get m plus 1 by m whole square plus 4m equals 0. So from here you are going to get m equals minus 1. Okay, so if m is equal to minus 1, what is going to be the value of c? This is c. C is going to be minus 4. What is the value of 2m minus 3c? 2 into minus 1 minus 2 plus 12, and the answer will be equal to 10. Option number D is the correct choice. Okay, let us move forward to the next section of this exam.